So continuing on here, we're going to look at another example where I need you to find the scale factor. So we have f prime, g prime, h prime, and I prime, which is this larger, rectangle. That image of f, g, h, I, the square down here. I guess that must both be squares. After dilation with the center at the origin, so down here. I want to know, what is the scale factor for this? Okay. Recall that the scale factor is the ratio of a side length in FGHI to a corresponding side length in F prime, G prime, H prime, I prime. Okay. This will be your numerator, okay, and this will be your denominator there. So I want you guys to take a moment on your own, see if you can figure out what the scale factor is going to be. You can either write it in the fraction form, and if it can't be simplified, go ahead and simplify that as well. Okay, so do that now. Okay, guys, so as I said, we're going to write a ratio where the image, and if you didn't write this down before, oops, that's supposed to be an A, sorry, image over the original, and you're looking at side lengths here. Okay, so I'm going to choose side length G prime to F prime. So when I count this out, okay, I get 5 units, so I'm going to put 5 here as the numerator. And when I look at the original, I have to look at the same corresponding side length. Okay, so I was looking at G prime to F prime. Now I have to look at G to F, and that is 1 unit. So the ratio, whoops, a weird one. So the ratio is 5 to 1. Which makes the scale factor be 5. So if you were to look at this, all of the ordered pairs GHIF, FGHI, as well as the side lengths are all multiplied by 5 to get what the new image is going to be. So it's a little bit of different transformation than we've talked about already before, because we're changing all the side lengths now instead of just changing the position of the image. Okay, so now we're going to look at what are the coordinates, of the image ABCD after a dilation with center 0, 0 and a scale factor of 2. So I want to know what all of the ordered pairs are going to be for A prime, B prime, C prime, and D prime. Notice that the original figure A, B, C, D, which is a trapezoid, is here, and you need to tell me, and the original ordered pairs are here as well, and you need to figure out what the ordered pairs of the image are going to be. Go ahead and take a moment and see if you can figure this out for yourself. Okay, guys, to find this out, it's important that we note that we have a scale factor of 2. So that means we can multiply each ordered pair, the x and y, by 2 to get our new ordered pairs. When we do that, so we have 2 times 2, which would get us 4. Negative 2 multiplied by 2 would get us negative 4. Then we're going down to b and b prime. 2 multiplied by 2, once again, is 4. 1 multiplied by 2 gets us 2. Going down to C and C prime, 4 multiplied by 2 is going to get us 8. And 0 multiplied by 2 gets us 0. Okay. Then looking at D and D prime, 4 multiplied by 2, so we said before is 8. And negative 1 multiplied by 2 is negative 2. Okay. So these are the ordered pairs that you should have gotten. Now, if you were to graph this out with those ordered pairs, this is This is the image of the new trapezoid that you would get, and those are the ordered pairs that we talked about before. Now, one thing to note here is that when you have a scale factor that's going to be greater than 1, and this is definitely something that you should write down if you are taking notes following along, a scale factor that's greater than 1 is what we call an enlargement. Okay, the word large is in there. We're making the original figure bigger. So the image is larger. So we're enlarging the original figure to something greater. And that's exactly what this says, because the image is larger than the original figure. Okay, that's why we call it an enlargement. It's just larger. Okay, let's keep going on. So now I want you guys to tackle this one. So what are the coordinates of the image PQRS after a dilation with center 0, 0 and a scale factor of 1/2? So here's our, looks like it's another square. So PQRS, all right. And now we're gonna have, you're gonna dilate it with a scale factor of 1/2. Okay. Note what your scale factor is. Your scale factor is half. So, so in this case, your scale factor is actually less than 1. And when you have a scale factor, I'm going to underline, and this is something you should probably write down. You should write down as well. When you have that scale factor that's between 0 and 1, this is what we call a reduction. Notice how here's our original figure, and our image is smaller now because our scale factor is less than 1. It's in between 0 and 1. So this is what we call a reduction. We're reducing the size of the original image. That's because, or the original figure, and that's because the image is going to be smaller than the original figure. So here's your original ordered pairs, P, Q, R, S. I want you guys on your own, see if you can figure out what the ordered pairs of the image are going to be. Go ahead and do that now. Okay guys, to figure this one out, you are going to have to multiply each one of the ordered pairs, the x and y, by the scale factor 1/2. So when you do that for p to get p prime, well, 6 multiplied by 1/2 is going to get you 3, and 10 multiplied by 1/2 is going to get you 5. So if I remove this off to the side, I'll make it a little smaller. Okay, I move that off to the side. You see that p prime is 3, 5. And if we could check that, there's 3 and there's 5. So q is 10, 10. So q prime, when multiplied by a scale factor of 1/2, 10 multiplied by 1/2 and 10 multiplied by 1/2 would get us the ordered pair 5, 5. So q prime is 5, 5. R is originally 10, 6. When multiplying that by the scale factor, 10 multiplied by 1/2 is 5. 6 multiplied by 1/2 is 3. So we get R prime is 5, 3. And our last one here, we have S, ordered pair 6, 6, multiplied by a scale factor of 1/2. 6 and 6 multiplied by 1/2 is 3. So you get 3, 3 as your final ordered pair. Okay, moving on. So now we have a dilation that maps point L up here, 3, 6, to its image L prime, which is 2, 4. Complete the dilation of figure L, M, N, and label the image L prime, M prime, N prime. And then figure out the scale factor and what the length of side M prime, N prime is. So let's go ahead and figure out. Let's complete the dilation here. See what else we can figure out. So I'm going to grab that pen, complete the dilation, and we're going to label it out. So notice we had L going down to L prime. We're also going to need to draw another dotted line. And I'm going to do my best here, running from the origin to M, as well as, I'm gonna try to do my best here, my lines, as well as the origin through N. Okay. So notice from here we can actually get our scale factor kind of just by looking at our 2 points here. So we have L, which was 3, 6, and L prime, which was 2, 4. Okay. To get this scale factor, you actually only need to choose either the x coordinate or the y coordinate for each one. I'm going to go ahead and choose the x coordinate to make it a little simpler. Okay. Remember, it's a ratio of the image over the origin, so I over O. So we want the x-axis of the image, which in this case is going to be 2, over the x-axis of the original, which is 3. So our scale factor for this is going to be 2/3, or 2 over 3. This would also work if you chose the y-axis. So if instead we chose the y-axis coordinates, it would also work. The image would be, I'm going to write it over here, would be 4 over the original would be 6, or 6, which simplifies down to 2/3. Okay. So it kind of works a little bit like constant proportionality when we've talked about that before, or maybe slope. It ties into that. It's not the same, but it's that same idea of a ratio that's going to be constant throughout the figure and the image. Okay. Well, so now that we know this, we could figure out the rest of them. So M is 3, 3. Okay, well, if we multiply that by the scale factor 2/3, so we know that 3 multiplied by 2/3 would get us 2, and then same thing with the other one. So M prime would be here. N was 6, 3. 6 multiplied by 2/3 gets you 4. And then 3 multiplied by 2/3 gets you 2. So N, actually N prime, falls right there. Here's our, our image. It's my best attempt. Image of our new triangle. So then the length of M prime to N prime, we could count, be 1, 2. You could also check that by looking at this distance. This distance from M to N was 3. You can multiply that by the scale factor 2/3. 3 multiplied by 2/3. Okay. And that would end you up with 2, which is our distance for M prime to N prime. Okay, last one here, guys. So I want you to try to figure out the scale factor for this dilation below. Now notice your original is D, E, F, G. Go a little bit backwards here, D, E, F, G. And the image is D prime, which D prime, it's hard to see, but D prime is in the exact same spot as D at the origin, so it didn't move. Okay? So then I want you to figure out what the scale factor between D, E, F, G is, and D prime, E prime, F prime, and G prime is. Take a moment and go ahead and see if you can figure that out now. Alright, so to figure out the scale factor, recall you need to have that ratio of the image over the original. I'm going to make it so it's R equal, because R is scale factor. So we need a length from the image and a length from the original. I'm going to go ahead and use the length from D prime to G prime. And just always feel comfortable using that length. You could use G prime to F prime, whichever one you want. I'm going to use D prime to G prime. So D prime, G prime over So the length of d prime to g prime is 12, length of dg is 4, which gets us a scale factor of 3.